So first of all, there's the terminology there, guys. The importance of terminology in maths is more so that you can understand explanations than it is about us going to ask you the definition of something. Okay. Simplifying algebraic expressions. Please remember, when you're adding or subtracting, you can only add or subtract like terms. So like terms are the terms that are exactly the same variable with the same exponent. And then the numbers in front work like they normally would. I try to tell people to help them remember that the symbol over here is not just for movies, okay? And that last one might not look like a V, so I'm just going to undo it quickly and do that like that. Okay, I use this symbol to remind us that for every single term, the sign comes first, then there's a number, and then there is a variable. Okay, sign, number, variable. And the reason why that's important is I want you to remember, for example, this negative 3x to the power of 3, that negative belongs to the term. It is not just a subtraction sign. It's not just saying minus. If you move the term around, that minus belongs with the term because the sign is actually the first part of the term. Okay, so please remember like terms. Then multiplying. So products is the next big thing. I'm going to fly through some of them, slow down through some of the others. So we've got a monomial times by a polynomial. This you learned, I think, for the first time in grade 8, and that is distributive law. Every term on the inside gets multiplied. Now, where I find people getting a little bit confused here is they forget the explanation. It is every term. So if I've got 2a squared and then inside here I've got 3a times 5, do you see that inside the brackets? I want you to all tell me in the chat now, please. Inside the brackets, how many terms are there inside the brackets? Okay, I've got 3 answers, 4 answers, 5, 6. Okay, the majority of you got it right. Okay, and if you want to type in the chat directly to me, guys, because I see you are chatting to everybody, then that's nice because the other people don't see your answers, okay, and they don't land up cheating by just copying your answers. And it's also nice because then I'm the only one who knows what everybody has said. So I'm more than welcome. You can direct message me and I will still see it. There's one term inside. Oh, sorry, now I'm mixing my numbers and my writing. There's one term inside those brackets. Remember, terms are separated by plus and minus. So my distributive law says that I need to multiply by every single term. So this 2a squared needs to just get multiplied once because there is only one term in there. It is not the same as if I had the 2a squared and then 3a plus 5. That's 2 terms. And in this situation, my distributive law would have to multiply by the 3a and it would have to multiply by the 5. But my first example, it was just one term. So we're just going to multiply everything because it's all one term. So it's 2 times 3 times 5, which is going to give me 30. And then a to the power of 3. Okay, please let me know if you are uncomfortable with the reason why that is 30a to the power of 3. Whereas the example underneath would have been a 6a to the 3 plus 10a squared. The difference between the times, which I know looks like 2 terms, and I think that's why everybody falls into that trap. Unless there's a plus or a minus, it's all still one term. So that would have been multiplied in just once. So everything was just getting multiplied. And please take note of the 2 different answers that we get. Okay. So that's the first thing that I feel like is a big thing that everybody gets caught with. The next one's a binomial times a binomial. You guys will know it as a FOIL. So FOIL is the way that we tend to best know it. Whether you call it FOIL or you have another way of remembering, the big thing is every term on the inside gets multiplied by every term on the inside of the other brackets. Okay, the way they use FOIL is they say the first, the outers, the inners, and the last. And there's 2 examples there. I'm speeding through that. If it's something that stresses you out, let me know. Okay, squaring a binomial. Now you'll see they've given you a shortcut here. I first of all want to stress you do not have to use the shortcut, but we are in grade 10 now, okay? So I am actually expecting you to start using the shortcut because we don't allocate as many marks to it as we would have before. So this example over here is the same as saying P plus 2R times by P plus 2R. Okay, it's exactly the same. And do you see here, you are more than welcome to use FOIL, which we've known how to do for ages. Okay, so if that makes you more comfortable, then that's perfectly fine. But it is time to start getting used to the fact that we've got more than one term here. So square the first term, multiply the first term by the second term and double it, and then square the last term. That is something that you should be able to do in your head and get straight to the answer. So if we have a look here, squaring the first term would give us P squared. Multiplying these guys by each other, so P times 2R, and then doubling it would give you your next term, and then squaring the whole of the last term. So you land up with 3 terms when you square that binomial. Not to be confused again, notice how many terms are inside. I'm going to underline again. How many terms are inside the bracket for this example? Type it in the chat. How many terms are inside that bracket in the example? Okay, awesome. Yes, brilliant, guys. Okay, so now if I have a look at a slightly different version of that, if I had P times 2R, how many terms are inside? I've underlined it in red, the new example that I wrote down. How many terms are inside there? Okay, brilliant. The reason why that's important is because when there was just one term in it, we get used to the fact that if there's one term in there, I can just say P squared times 4 times R squared. Okay, everything inside the bracket just gets squared, but notice the difference. Okay, the one was one term. When it's one term, we can just almost apply that exponent to everything. When it's more than one term, we cannot do that. Okay. So please just be aware of that. And the short step is optional, but it is recommended. Okay. Let's move on. Okay, difference of 2 squares. You guys should be more comfortable with this in factorizing. That if we have a look at difference of 2 squares over here, this is a situation where we're multiplying out. It's 2 brackets. Again, you are more than welcome to use FOIL. But if you notice the differences, then you can do quicker calculations during your tests, which helps you with time management. Okay. So if you have a look at this situation, it is the 2 binomials, that's 2 terms, multiplied by each other, but they're exactly the same except for those pluses and minuses. Okay, there's a minus and there's the plus. If they're exactly the same, the only things you have to worry with the FOIL is the firsts and the lasts. And the reason why is because your outers and inners will always cancel out. Okay. Only when they're the same brackets, one with a plus, one with a minus. Okay, so just be aware of that. And I'll show you, there's a couple of examples here, but I'm going to show you the last example we're going to focus on, because in this last example, it actually became very useful, because you'll notice there was an A minus B plus 5, and then an A minus B minus 5. They are exactly the same, except for this plus and this minus. Okay, so if we didn't notice that there was this special situation, we would have had to multiply everything out and it would have been messy. Not wrong, it just would have taken a long time. So for example, we would have had the a minus b and we would have had to times that by a minus b. Then we would have had the a minus b and we would have had to times that by the -5. Then we would have had, I'm running out of space already, we would have had the 5 and we would have had to multiply that by a minus b. And lastly, we would have had the 5 and we would have had to multiply it by the -5. We would have had to do all of that multiplication, then all of that adding and subtracting of like terms. It's not wrong, but a quicker way is to just square the first term. That's my firsts, okay? And then multiply the last one, +5 times -5, it gives me -25. So all we did was our firsts and our lasts, and then we got there quite quickly, okay? So that is the difference. Being able to notice these shortcuts are useful, but please realize that all of the ones that I've just done now, you can still revert back to your normal FOIL, okay? We're not showing you that FOIL is no longer needed. These are special cases of FOIL. Okay. Binomial times a trinomial, it's the same concept as FOIL. Every single term in the first bracket gets multiplied by every term in the second bracket, and then you add and subtract your like terms. Okay. Mixed questions. This is them just mixing everything up. So there's some distribution. Please notice this minus belongs to this entire term. My recommendation here, it is not the only way to do it. Remember here we got a sign is your first thing. So that minus belongs to the whole thing. So multiply out your brackets first. Okay. So you'll see here they're going to multiply out those brackets, but they've left the negative just in front. Because that negative still needs to get distributed after you've multiplied the two brackets in, okay? So that's what you need to be careful of. Careful of the negative signs whenever you've got these mixed examples. Okay, now we're going to factorization. Before I move on to factorization, I'm just taking a quick pause. If there's anybody who's stressed out about anything, please let me know. So that I can make sure we're sorted before we go into factorization, which is the opposite of products. Okay, so basically products we're multiplying out. And now factorizing is going back to what we had before. Okay, so if we don't understand our products, the factorizing can be a problem. Okay. Great, it all looks good. The purpose of factors is basically to split something up that's all messy and complicated, to try and split it into things that are multiplied by each other. So I know this doesn't look complicated, but if we had a 25, that is the same as saying 5 times 5. The factors 5 and 5 get multiplied by each other, which means I can write it as 5 squared. That's kind of the concept, but we're doing it with algebra. So we're going to follow these steps. Factorization is very important. So look for a common factor first, always. Then count your number of terms. So all of these things here, the binomial is telling me I've got 2 terms. So now this is why it's important to remember what a term is. A trinomial has 3 terms. And then 4 or more terms, you're going to look for things like grouping, or possibly there might be a fancy difference of squares, things like that. Don't forget to factorize as far as possible. So once you're done, check to see if one of your brackets could factorize further. And remember, the terms in brackets can be taken as a variable. Okay. Okay, so your highest common factor, we're breezing through that. And we're going to breeze through a couple of these factorizations because you did actually start it in grade 9. So again, if you need me to slow down on a certain factorization, let me know. Here, this is a nice little trick where you can change the sign. if you got B minus A, notice the B is positive, the A is negative. By taking a negative out in the front, you change the signs of what's going on inside. So now the A has become positive and the B has become negative. That helps us to simplify out, okay? But please take note, it only works when one of them's positive, one of them's negative. If they're both positive, you can swap them around, no problem. But if you got B minus A, you can't just swap them around. So we do that trick where we take the minus, but there was only one negative in there. Okay, difference of two squares. You also did that in grade 9. So there's two terms. They're both perfect squares. And please take note, it has to be the difference. Grouping, okay, this is where I'm going to slow down. So we're going to do one of them with grouping. You'll see your course note says put them in brackets first. And it's not a bad thing to do. There's a lot of times you get confused with signs. Please just, if you put them in brackets, notice in between the brackets, there's a plus sign. Okay, and the reason why I say that is because I see far too many children who they remember to put it in brackets and they do that I've just shown you there to the question. But the problem with that is it's actually changed the question because in between these brackets, it's telling me to multiply, whereas it didn't tell me that before, okay? So the brackets is very useful because it helps people to make sure they don't do funny stuff with their signs if you remember to put a plus in between them, okay? And then you take out the common factor from the first bracket, the common factor from the second bracket, and your whole goal is to get the same bracket. So if you don't get a common bracket, guys, you need to do something else. So either you grouped them incorrectly, which was this first step, and you've got to group different terms together, or you need to use, do you see as a D minus C and a C minus D? All you need to do is change the sign. So you take a negative out and swap it around, okay? So that is what you're going to do when you're factorizing with grouping. There's two more examples, but I know we've seen all of these. So sorry, I'm just quickly catching. I see I've got a message. Okay, no. Okay, so that's all the grouping. Please remember the grouping might be a little bit different. So here, instead of grouping two things together, they've grouped the first term as all on its own, and the last term became a bracket squared. So the whole thing creates a difference of two squares. Trinomials. Now, I think this is where everybody struggles the most with factorization. So I'm going to do a couple of examples with the trinomials. Okay. First of all, step 1, trinomial. How do we recognize we're doing these steps? You've got your variable as being squared. It's what we call a quadratic trinomial is actually the full word. Quadratic means our variable is being squared. So you put it in standard form. That means one side is going to be 0. Okay. Then you need to factorize the trinomial. Oh, sorry, I'm jumping to equations. This is what we would do for equations. Okay. Sorry, so I was jumping a little bit ahead there. So you're going to have to factorize this fully. Now, there are a couple of methods to do it. I'm going to focus with what they've done in the course notes. Please, you do not have to do it that method specifically. We don't mark the method. In fact, we tend to mark your final answer. So a way to help you is we're going to go the 3 times the 2. That's what they said here. Multiply the first and last terms. So 3 times 2 gives us 6. Then we list all the factors of 6. So it's 1 times 6 or 2 times 3. I need to see which one of those, the 1 times 6 or the 2 times 3, is going to give me a positive 7. Okay, so now if I have a look at that, if I were to add them, it would give me a 5. So 2 plus 3 would give me 5. Obviously, subtracting makes it smaller. But if I look at this one, I go 1 plus 6 and I get 7. Okay, so after I've looked at the factors, I see which of them is going to give me that middle term. And I see it's the 1 and the 6. So I want you to rewrite, okay? You're going to rewrite that middle term That's 7x. It has to still look like it will land up being a 7x. Do you see I split it up into two terms? So I'm using the 1 and the 6, and I figured out the 1 and the 6 here on the right, okay? I know that it has to be a 6x plus a 1x. Does the order matter? No. So please don't get stressed out. Must it be 1x plus 6x or 6x plus 1x? It'll work out no matter what you do. And then you can do your grouping. So you see in these first two terms, I've got a common factor of 3x. And in the second two terms, there wasn't a common factor. So I just put the plus in the middle. Now you should have a common bracket, and then you get a 3x plus 1. So this is a way you can do trinomials where you're using your skill from grouping that we did earlier. Okay, same thing here. We're going to go 6 times 12. 6 times 12 gives me 72. Here we're checking my quick maths. So we've got 1 times 72. I'm looking through all my factors of 72. Why 72? Because those guys I multiplied. I could go 2 times 36. 3 times 24, I think. Okay. And you can carry on through all of them. I'm not going to go through all of them, but you'd carry on through all of those. This is the last trinomial I'm doing slowly. And then what we notice is to get that 17 in the middle, I would have had to use the 9 and the 8, which I would have eventually got to. I would have eventually got you 8 times 9, which would give me the 17, but I need negative 17. So please notice that changed them to negative 9ab and negative 8ab. Then they do grouping again, and that gives you your 2 brackets. Okay, this is a little bit longer. Some of you might have learned just to fiddle with the numbers, and that is perfectly okay. You're more than welcome to do that, please. In fact, it's generally how I prefer it, but you know what, in your grade 10, you're doing the slightly longer version is perfectly fine. Okay, here's some more examples. And then we get to another one, which is a special situation where we have our trinomial. The first term and the last term are perfect squares. And this middle term, which is a little bit tricky to sometimes check, this middle term is made up by the square root of the one term times by the square root of the other term times by 2. Now that should look familiar. It's like when we had our binomial squared, okay? We had to multiply the 2 terms and then double it. Okay, so if I take the square root of those 2 terms, which basically is what they've done for the answer, do you see if I multiply and double that, it does give me that middle term? Okay, again, you have to recognize it. And do we have to always recognize it? No, it just means it'll be quicker. Okay, so that's again a special case of your factorization. Okay, sum or difference of 2 cubes. This is a rule that you learn. So there's 2 cubes. It doesn't have to be a sum. It can be a sum or a difference. Okay, and you're going to cube root both of them. That gives you your first 2 terms in your first set of brackets. Then you need another bracket. And to get that, you square the first term of your first bracket. Okay, not the question. You're squaring this guy here, the 2a. Then you're going to multiply them and change the sign. Not multiply and double. You multiply and change the sign, opposite sign. And then you square the last term. Those 2 brackets together give you your answer. So you should land up with 2 brackets. One's got 2 terms, one's got 3 terms. Guys, it's literally learning what to do. So I'm going to fly through those. The steps are there. And it doesn't matter if it's a fraction or not. Okay. Algebraic fractions, please remember multiplying, you go straight across, dividing, you tip in times. So that's the same. The only thing that's different is you need to factorize first if you've got more than one term. So do you notice here in that example here, these were one term over one term in your fractions. The minute you've got more than one term, That means you need to factorize first. And if you don't know how to factorize, you can't do these. Okay. But we've gone through the factorization. So I'm flying through those. For addition and subtraction, and please note it's only when you're adding or subtracting fractions, you're still going to factorize first, but you then need to find your lowest common denominator. And basically every factor must be included in your LCD. Okay, so if we have a look at this first example, first thing they're going to do is factorize. So there's my factorized denominators. Every factor has to be in my denominator. So this is an x minus 3 is in my denominator. X plus 2 is in my denominator, my LCD. X minus 3, I do not have to repeat it because it's there already. Okay, and x plus 2 is there already. So that makes up your LCD, and then you convert everything that's already over the right denominator. Here you have to multiply by x plus 2 at the top and bottom. There you have to multiply by x minus 3 at the top and bottom. Okay, restrictions for fractions. So make sure you remember your denominators can't be 0. Please take notice of the different wording. I hope they're coming up the screen. Yeah, they are. Okay. Different wording. Please notice that the first question says, determine the value for which the fractions will be undefined. They're asking for a value. So you're going to tell them what that value is equal to. Here it says, determine the restrictions of the following fractions. So both of them fall on the same concept where we make our denominator 0 and we solve that equation. But please notice when they ask for restrictions, I said not equal to. When they're asking for the value, I'm saying they are equal to. Yes, I know that they're the values they're not allowed to be, but that's what they've asked for. It is likely you might get your marks either way. But if it's something you can remember, then that's why I'm highlighting it, because mathematically you need to use those correct terms. Okay, guys, before we go on to exponents, I actually want to go to, actually, no, let's do this first. You've got all of these rules, and then we're going to do some questions and memos. All of these rules that you first learned in grade 9. Okay, I want you to notice something with all of these rules, and it's something I did mention earlier. They are all one term. So please don't try and use these rules unless there's one term. I'm basically focusing on, remember when we had x plus 3 all squared, I couldn't do this rule that we've used over here in number 3, because you'll notice the rule has only one term, where my question had 2 terms. So there we had to use the FOIL. Okay. So that's the first thing I want to make sure you realize. All these exponent rules are for one term. Big thing is you need to have the bases the same, and then the bases will stay the same. So what the new thing is, we sometimes bring in numbers as our bases. And because the numbers are there, we tend to forget the fact that when we use those exponent laws, and I'm actually going to go back again to them quick. Please notice here, the bases were both A for the first law, but we're multiplying. The base stayed in A, and then we just added the exponents. The only thing that changed was the exponents that changed, because they're exponent laws. Okay, so please remember that. So even if there's a numerical base, so we prime factorize on our calculators. So the 18 is the same as 3 squared times 2. Please let me know if you do not know how to get the 3 squared times 2 on your calculator. Okay, because it will save you time. The 9 is the same as 3 squared. The 16 is the same as 2 to the 4. So that's what we call prime factorization. We're changing all of those numbers to prime factors. Then we can use the law where we multiply, because do you see that there's only one term on the inside? Okay, there's one term on the inside. So we multiply the exponents. Lastly, when my bases are the same, I can use the laws. So for these two 2's, the bases of 2, I can add the exponents and get 6n minus 3. For the bases of 3, I can add the exponents and get the 4n plus 3. But notice the base stayed a 2 and it stayed a 3. We didn't multiply them. Okay, the base stays the same. Okay, addition and subtraction. Guys, remember I said if you want to simplify, if there's one term at the top, one term at the bottom, you're good to go. But if there's more than one term at the top and more than one term at the bottom, your first step is to factorize. The minute you see more than one term, so that addition and subtraction, you have to factorize before you can simplify anything. Okay. So you can see what we do is I call it break it down. Okay. So you're going to take this 2 to the n minus 1 and you split it up as 2 to the n times by 2 to the minus 1. That's multiplication. If I were to add my exponents, it would get me back to that. So I'm splitting it up now. I'm breaking it down, whereas normally I'd build them up together. Okay. And doing that allows me to find that common factor to make factorization easy. And then when we factorize, oh, look, now that there's one term at the top, one term at the bottom, they're allowed to simplify. And then I've just got numbers, and I know the majority of you would just type that into your calculator and get your answer, and that'll be fine. Okay. So again, these course notes, we've gone through lots of them and done them lots of times. So I'm just flipping through them. Okay, exponential equations, which is a little bit linked to our equations. The big goal here, wait, I think there's an example before this. Oh, no, there isn't. Okay, it must be coming later. Apologies. Okay, so the big thing here is to get your x on the own when it's the base. So that's no problem. If it has a power of 2 over 3, we've isolated the power. And then we're going to write it back into what we call surd form. So when you've got a fraction in your exponent, the number on top is the all power for power. The number on the bottom is like the roots of trees that are underground. Okay, so the number at the bottom is going to be your root. So do you see that that 3 at the bottom became a cube root, and the 2, the all powerful power, becomes a power. It's an x squared. And then you're going to undo that. So to get rid of cube rooting, we cube it on both sides, and then we square root both sides. Remember, plus minus whenever you square root. Here we isolate the powers. The difference between this question and the last one, the x was in the base last time. Do you see this time the x is in the exponent? So we're still going to get the power on its own. What I mean by the power is the base with its exponent. But then on the other side, I need to have the same base. So the 27, I have to write it as 3 to the power of 3. Okay. Then when they have the same bases, the exponents must be equal as well. Okay. And then you just solve like a normal equation. Okay, and those are your exponential equations. Okay, so now we're moving on to equations and inequalities, but before we do that, let's practice this algebra. So let's go to the questions and memos. I want you guys to have pen and paper out. I want you guys to be doing this with me. And if you're brave enough to unmute, I would love to hear from you as well. Okay, so let me close that. Questions and memos. Let's have a look at some of this algebra. We will do the equations and inequalities in our next session. Okay. So over here, first thing it's asked us to do is to factorize. Okay. So factorizing, remember all the steps. Look for your highest common factor, then count your terms. The number of terms tells you what method of factorization you're going to do. Okay, we'll do the first one. Is there anybody brave enough to unmute and do it with me? So this is the part where we're all unbrave, or I don't know, we're all just eager to do it on our piece of paper on our own. Okay. Okay, let's repeat the steps again quickly. Guys, whenever you're factorizing, first thing, look for a highest common factor. Okay, that's number one. Then number two, count your terms, because that tells you the methods that you could use. Okay, so if you didn't have a highest common factor, you're going to count your terms. If it's two terms, then we're going to use dots or the sum or difference of cubes. Okay, dots, guys, is the difference of two squares. Okay, we've got an answer from Tanith. Thank you very much. 3 tells you that it's a trinomial if there's 3 terms. And 4 terms tells you that you're going to try and do grouping. Okay, that's basically the process. Always remember, after you factorize, your last step is check if we can factorize some more. Okay, so those are the basic steps when you're factorizing, guys. It is there in your course notes. So please, the course notes are good crib notes. You're only ready for your exam, though, when you no longer need to look at those crib notes. Okay. Okay, in all that panic. Okay, so let's quickly have a look. So I've got an answer from Tanith. I've got an answer from Rafense and from Emma. Okay, so the first thing I want to know is what method are we going to do? What method are we going to use? Okay, I've got a suggestion of dots. I've got a suggestion of highest common factor and then dots. Okay, take out common factor, then dots. Okay, guys, so the easiest way of doing this is to take a highest common factor first and then dots. But I'm actually going to do it in the I'm writing an exam and I'm confused way. Okay, to show you that you guys will still get the same answer. So if you didn't see the highest common factor and you just saw 2 terms, perfect squares, we're going to go for dots. You're not going to get the wrong answer. So remember dots, you're going to square root both sides and you're going to land up with a 2y plus 4 and a 2y minus 4. There's nothing wrong with that. Okay. And for those of you who saw the highest common factor first, that is better. Okay. But I'm going through to make sure everybody gets the same answer, even if they didn't see the highest common factor. Remember the very last step I said, always check to see if you can factorize some more. Do you see that this guy here has a common factor of 2? So that would become y plus 2. I can factorize some more there. This guy here also has a common factor of 2. And then do you see if I multiply those 2's, I get 4 and then y plus 2, y minus 2. Okay, which is the answer that I've seen coming through. So thank you everybody for sharing your answers. Thank you for sharing me the method that we're going to be doing. So the first step was best to take out your factor of 4 and you get y squared minus 4 and then to use the difference of 2 squares. But if you didn't notice it, please see, as long as you do that third step, make sure that you can factorize everything as far as possible. You will still get to the same answer. Okay, so that was number 1. Let's see if we've got anybody who's a little bit braver now. Number 2, who's going to do it with me? Number 2. Okay, so it does say factorize in the instruction. Often in a test or an exam, though, this factorized question actually might just say simplify. Okay. And sometimes you need to just know that you're going to be factorizing. Okay. Okay, so I've not no takers. That's perfectly okay. Let's have a look. Guys, if I was going to simplify this or factorize, I'm going to start with my numerator. Tell me what method can I use? Remember, first look for highest common factor, then count your terms. Okay, what method could I use for number 2? Type in the chat. I need to make sure you're all still with me. And if you have no idea, then remember that's just as important. Tell me that I don't know what to do. Okay. So we've got some suggestions and we've got some I'm really lost. Okay. So we're going to have a look at this first one over here. We're focusing on the numerator. And I said, if you've got 2 terms, you've got 2 choices. So it's either going to be difference of 2 squares, which I'm hoping you guys see it can't be. Okay, because 1 is a perfect square, but x cubed is not a perfect square. So we cross that out. That option is not going to help me. The only other option we've got is the sum or difference of cubes. Okay, and guys, this is learning work. So please go back to the course notes if you don't remember it and learn the process. The sum and difference of cubes. The first step is you cube root everything that's here. So I'm going to cube root that one, and I'm going to cube root that one, and I'm going to get x minus 1. Okay, that is the first step that you've learned. Okay, then there's going to be a trinomial next to that. To get that trinomial, I'm going to square those terms for the first and the last. So this is going to become an x squared at the beginning, a plus 1 at the end. And then I'm going to multiply. Let's not write the word. I'm going to multiply and change the sign for the middle. So if I multiply, I'm going to land up with x times -1 is negative x, but I've got to change the sign in the middle. So that is how you do it, and that is learning work. Okay, that there's no sort of further explanation other than please learn it. That's how my numerator is going to look. Okay, then the denominator. Count how many terms. What method are we going to use in the denominator? And I hope the question mark I got for they didn't know where to start. I hope that made sense. Please let me know if you're still stressed out about it. Okay, yes, I got a couple of answers here. Trinomial, awesome. Okay, great. So we've got trinomials there. Guys, you're more than welcome to do the grouping and tell me if you want me to go through all those steps for grouping. But I know I need an x times x to get me the x squared. I need a 1 times a 1 to get a 1. And then I want to put here, I don't know what, if I put 2 pluses, do you see it's wrong? And if I put 2 minuses, it is going to be wrong. And if I put 1 plus and 1 minus, it's going to be wrong. Do you guys all see that? Do we get stuck when we're trying to figure out the signs here? If you're not too sure why it's wrong, just tell me which one you thought was right, and then I'll show you why it's wrong. So you can either put plus, plus, minus, minus, or plus, minus if you thought it was right and you don't understand why it's wrong. Okay, but if I don't get any of that, okay, so let's try the plus, minus. Let's have a look. Yes, Emma, I'm getting to a point. Thank you very much. I'm glad you're on the ball. Okay, so we've got queries with all of them. So I'm going to show you for each one of them that they're wrong. So here we're just going on the side. If I had x plus 1 times x minus 1 and I multiply it out, that's going to give me x squared minus x plus x minus 1. Do you see that gives me x squared minus 1? It is not the same as that denominator. So do you see why the plus minus is wrong? Okay, 2 pluses. Let's have a look at 2 pluses. If I multiply that out, I'm going to get x squared plus x plus x plus 1, which gives me x squared plus 2x plus 1. Do you see? It is not the same as my denominator. Last one, if I try x minus 1 and x minus 1, I'm going to get x squared minus x plus 1, which gives me x squared minus 2x plus 1. Guys, and if you're struggling with the trinomials, I highly recommend whenever you've got your two brackets, quickly multiply them out. It doesn't have to be part of your sum. Just multiply it out and check that it is the same thing, because then you would have realized that none of those are going to work. Okay. But then Emma made a good point. We're so eager to factorize, guys, that we're forgetting that, remember, this was one whole fraction, and maybe it's because of the way I wrote it. And in the denominator, do you see that this trinomial is exactly the same as that trinomial, and they will just cancel out? So I don't need to factorize. Okay, do you see that we don't need to factorize that at all? Okay, so these guys would have actually just canceled out. And that gives me an answer of x minus 1. Are we happy? If I don't share any concerns, I'm going to assume that yes, we're happy. I want to do just a little bit more, and then we're going to take a bit of a break. Great. Okay, so guys, I want to try and get to an exponent question. So I want to get down here to B number 2. Okay, I want to quickly do number 3. So I'm going to do number 3 just quick without any questions here. How many terms? Well, actually one question. How many terms? Count the terms and then tell me what method of factorization are we going to do? Okay, so yes, we've got the right number of terms. So what type of thing do we look at if we've got 4 terms? Great, grouping. Okay. 4 terms, so we're going to look at grouping. And I look at these first 2, and there's no common factor, so I'm going to put it in brackets. Then I put a plus, and then I look at these next 2 over here, and here I've got a common factor of y, and that's going to leave me with 1 minus x. And I look at that and go, oh, yes, I got a common bracket. Oh, damn, no, I don't, because they are so close. Those brackets are so nearly the same, but they're not. So it makes my heart sad. In my heart of hearts, I want them to be the same. Okay, so we're going to change the sign. Absolutely. So I'm going to have an x minus 1 here. I'm going to change it to a negative y, and then I get to swap it around, which then gives me exactly the same bracket. And please don't forget, when it looks like you've taken everything out, you're left with a 1. Okay, let's quickly do the exponent question. Is anybody brave enough to tell me or do the exponent question with me? Anyone brave enough to? You guys quite enjoy typing in the chat. Okay, as long as you guys are working on the other side and telling me when you're confused, I'm good. Okay, although I do like hearing your voices instead of mine all the time. Okay, let's have a look at number 2. What's the first step if I want to try and simplify this guy? There is only 1 term at the top, 1 term at the bottom. So normally I can simplify straight away, but the exponents make there a bit of a problem. What is the first step? Okay, factors. Okay, guys, my bases all need to be the same. Okay, so I noticed with you guys chatting, you weren't too sure on the correct words. It's prime factorize. Okay, guys, so yes, we're going to prime factorize here. The 16 is going to be the same as 2 to the 4. The 12 is the same as 2 squared times 3. If you want to use the dot instead of the times sign, it is exactly the same thing. And then at the bottom, we've got 3 to the x, and then 2 squared to the negative x. Okay, we can use our exponent laws because there's 1 term everywhere. Okay, so that is going to become 2 to the negative 4x. Remember, you multiply your exponents. Then I'm going to get 2 to the 2x plus 2. Guys, our last question before our break. And then finally, 3 to the x times by 2 to the negative 2x. The reason we had to prime factorize is please take note of all the same bases that we can now simplify further with. Okay, and you needed those bases the same, otherwise you wouldn't be able to simplify. So remember, when you're multiplying, you add exponents, and when you divide, you subtract your exponents. Okay, so I know that typing can sometimes be tricky. So if you can give me the full answer, that's great. But first of all, give me your final exponent for the 2. Give me your final exponent for the 2. Type it in your chat. Final exponent for the 2. I am busy working it out, so I have not given you the answer yet. When I was multiplying, I added my exponents, and then subtracting, be careful, do you see I'm going minus the negative 2x? Okay, and your final exponent for the 2 is going to be 2 squared. All I've done is the 2 so far. Okay, then I want you to do it for the 3 as well. Okay, tell me what your final exponent for the 3 is going to be. When you're dividing, remember you subtract your exponents. And then that means you can finally give me a final answer without any exponents. What is your final answer? Awesome, Klinguwe. Awesome, Emma. You guys are rock stars. Awesome. Guys, we're going to go to equations and inequalities now. So let's have a look back at our course notes. Again, I'm going to breeze through some of the equations and inequalities that you guys should know and should be okay with. Some of them I'll go a little bit more slowly through, okay? The ones that I want to stress. So one of the new things you learned this year was simultaneous equations. And learning the methods, because there is learning work in maths, it's not just about practice. Learning the methods is a wonderful thing, but you've got to know when you have to use it. So the hint that we're going to use simultaneous equations is, first of all, there are 2 equations. So I can get 2 equations. Sometimes we have to create the equations in like a story sum. So the only time then that we'll know we need to do simultaneous equations is if there's 2 unknowns. So basically 2 variables. Okay. So that's basically how you know you're going to do simultaneous equations. Very often they would ask the question, giving you 2 equations like they've got here, and they'll say solve simultaneously. So the instruction even tells you, okay. So it's only really when you get to application that you would need to know. But solving simultaneously, you can see I've got 2 equations and 2 unknowns. There's 2 methods. I have never seen a test or an exam where it may be a class test because they're trying to make sure you know a certain method, but an exam where they tell you you must use elimination or you must use substitution. So it is completely your choice. Okay, so there's 2 methods and these are your choice. Okay, but as much as it's your choice, I recommend that you are comfortable with both. There's a reason why we teach you both, okay? So substitution is because when we get to grade 11, your simultaneous equations get a little bit more complicated and it needs substitution. When you get to grade 12, your number patterns gets a little bit more complicated and it's easier to do it with elimination. So both of them are skills that I would like you to be familiar with. But at this point in your high school career, you could probably choose. It's also a good idea to choose when it works well. So elimination works well when it does actually eliminate. So that means there's a variable, you can see here, plus y and minus y, they will eliminate. So you don't have to prepare anything, okay? And then substitution is pretty much every other situation when it doesn't eliminate. Otherwise, you're going to use substitution. Okay. So it's your choice, but I do recommend both. So the first one is you put them underneath each other like they've done here. Make sure the variables and equal signs and everything line up. And then you're going to add the equations. And you'll see that when I add my y's, they disappear, which allows me to solve for x. Once you've got x, you substitute back in, and then you solve for y. Please remember you need an x and a y. There were two unknowns. Okay. Substitution, you'll see that this method of substitution, they've labeled each equation A, B, and C. You're more than welcome to do it that way. I find just laying it out separately on my page makes my life easier. So I'm going to write that on the side. So I'll write on the left-hand side of my page, x minus y equals 8. Okay. On the right-hand side of my page, I'm going to write the other equation, 2x plus y equals 10. Now, at this point, you choose which equation you want. I'm going to do it the same as what they've done in the example. I'm going to choose the equation on the left, but you can choose the one on the right, and you get either x or y on its own. So I'm going to move the y, the y over, and I get x is equal to 8 plus y. And then we can take and substitute into my other equation. So everywhere I see an x, I am going to replace it. Okay, there's my x. I'm going to replace the x in the other equation with the 8 plus y. Okay, so we're going to have 2. I don't think the yellow is very easy to see, so let me change that. 2 times by the 8 plus y equals 10. Okay, then multiplying out, I get 16 plus 2y plus y equals 10. That gives me 3y. I'm just adding my like terms, equals -6. Y equals -2. And then I go back to the left-hand side. X is equal to 8 plus my y value is -2. And that gives me x is equal to 6. So if you do that, you don't have to number any of your equations. You're just basically following a flow diagram of a method. You start from one side. If you had started with the equation on the other side, your flow diagram would have just gone in the other direction. That's perfectly fine. So you can see here, basically I started here, substituted in that side, worked everything out, and then went back to this side. So I just sort of made a little bit of a flow diagram. I find that a lot easier to follow. So that is an option that you guys can use. Okay, guys, so that is your simultaneous equations. Here's another example. Guys, I'm not going to go through every example they've got. They can always apply these things to now story sum. So any of your equations could be applied to a story sum. Please just realize if you've got two variables, you need to create two equations. Two variables means two equations. So that's the only thing that's changed with the story sum. Story sums are never all exactly the same, so I'm not going to go through those either, but they're good to practice. Okay, guys, equations and inequalities. So now we're going to have a look at the inequalities. And the biggest thing that was new here, because the method is very similar to equations, is the different notations. Okay, so you could draw these things on number lines. You could draw them in what we call interval notation, or you can use the inequalities, which in primary school we used to call crocodile mouths. Okay, so it's all the different notations that becomes very important, but solving the inequality is actually very similar to what we did with equations. So let's skip that, and I want to get to this example. So here they said write down the equality again, because they're making sure you know what the number line and the inequality would look like. But we're going to go through this example here first. So like an equation, So I'm going to do the equation on the side so you can see how similar they are. So if this was an equation, actually, I'm going to do it underneath because otherwise I'm going to run out of space. Okay, because my handwriting is too big. Okay, so if it was an equation, we would have had 4 2x minus 1 equals 5x plus 2. First thing we would have done is distributed the 4. Please make sure you're okay with every single one of these steps. Gives us 8x minus 4 equals 5x plus 2. Then I need all my x's together. So the x's have to go together. And then I also need my constant terms to go together. So you do the opposite operation to get to the other side, okay? So here we would have basically been adding 4 on both sides. And to get rid of those 5 x's, we would have had to subtract 5x. Okay, and that would have given me 3x on the side. You'll see that your constant term disappears on the left-hand side. 4 minus 4 is 0. And then on the right-hand side, I'm just left with 6. You'll notice the variables disappeared. Okay, so that was me as slow as I'm going to go for the basics of equations. And then that gives me x is equal to 2. This is exactly the same process as inequalities. The only thing you've got to be careful of is if you divide or multiply by a negative, the inequality will change direction. So I'm just going to write here change direction, and we'll do an example of that now. Okay, but that's the only thing that is different. Okay, otherwise the process is exactly the same. You can see that's exactly what they did here. They distributed, they put the x's together, the constants together, and then they divided by 3. Dividing by positive numbers, okay. You'll notice the inequality sign stayed the same every single step of the way. Okay. The different notations, so your x greater than 2 is fine here. If it's got the little x greater than or equal to 2, that means it's going to be 2 and everything bigger than that. Okay, so it's equal to the 2, but you'll see because it didn't have the equal sign, the non-equal sign, just the inequality has an open dot. Okay, open dot. And then your line will go in the direction where x is allowed to be. So if x was greater than 2, do you see that crocodile mouth wants to eat the x? Sorry, I know this is very condescending, but it's the easiest way to understand. The hungry crocodile wants the bigger meal and it wants to eat the x. The bigger numbers are to the right of the 2. So that is why it went in that direction. Okay. If you were to use this in interval notation, that thing that does the inequality without the equal sign is a round bracket. Okay, so for this, they kind of look like coordinates. So I'm going to have a round bracket, the 2, and then I go to infinity, and infinity is also a round bracket. Okay, so that's what it looks like with the interval notation. So it looks like coordinates, but it's not, and you always go from small to big. Okay, every single time the smallest value must go first. Okay, let's have a look at the next example. Here there's 3 sections, and this is going to be an example where we have a negative. So it doesn't matter that there's 3 sections, just the difference is you're going to do it to all 3 sections instead of just the left-hand side and the right-hand side. And your goal here is you want x in the middle. Okay, that is your goal. So basically you want to get the x alone in the middle. So you're getting rid of everything else. So I need to get rid of the 3. So I'm going to subtract 3 from every section. Subtractings are fine. It's dividing or multiplying by negative. That's the problem. Okay, so you'll see when they subtract 3 from every single section, I get -5. In the middle, the 3 disappeared. And then on the right-hand side, it became a 2. Now notice, I am dividing everything by the negative a half. Dividing by a negative. Notice that the inequality changes direction. So they were going that way, and now they're going to the left instead. The crocodile's moving to the left instead. So when you multiply everything by -2 or divide by -1/2, however you want to see it, that is what you're going to land up doing, changing the direction of the inequality, and that gives you your answer. So this is in inequality format. They just changed it around. Notice the crocodile still eating the same things. They just went from smallest to biggest, which is a good habit, because as I said earlier, and the notation is the biggest thing. I want you to be aware of the different notations. So with the equal sign, it is a square bracket from smallest to biggest. And then the 10 didn't have the equal sign, so that's a round bracket. Okay, that's your interval notation. And on the number line, you do not need to tell me every single number. I'm going from -4 to 10. The equal sign says it's a colored in dot, the not equal sign, and it was everything in between because the X was in between that. Okay. Guys, I'm going to flick through the rest of these inequalities quickly so that we can get to practicing some of the questions and memos. But the biggest thing is your notations. Okay, these are reminders of different terminologies. Okay, so here's your linear ones. This is what you did from grade 9. So you'd multiply out your distributive law, and you would get all your variables together on the one side, constants on the other side, possibly divide at the end. We went through that in detail. Here you also did fractions when you were in grade 9, but the only thing with the fractions is there were only numbers at the bottom. You shouldn't have done fractions without numbers. Okay. And then literal equations means everything had variables, and then you have to get the H on its own. I want to focus on this new grade 10 stuff. So we're going to have a look at the fractions with variables in the denominator. Okay, now remember when we were doing fractions earlier in the algebra, the biggest thing was when we're adding and subtracting, we needed to get an LCD. To be able to do that, our first step was to factorize. Okay, that hasn't changed, even though there's an equal sign. Okay, so this is an equation because there's an equal sign, but it's exactly the same process, other than at the end, we're going to get an answer. Okay, so over here, we factorized first. Once we've factorized, we get our lowest common denominator. Now you'll see here, it says multiply every term by the LCD. That is the same as when we did in the algebra, and I'm going to show you that it's the same thing. If we wanted to get them all over the same denominator, so if I wanted that denominator x minus 2 was my denominator and the x plus 2, so I want everything to have the same denominator. Okay, so let's see what we would do. For this first one, I'm going to times by x plus 2. So it's going to become 3x, or should I say 3 times by x plus 2. For this one over here, it was already over the correct denominator. Don't forget the minus belongs to the whole thing. And then for the other one at the end, I have to times by x minus 2. Sorry, I know I'm trying to squeeze all of this in here. Do you see that that's exactly what I've landed up with at the bottom? I'm color coding so that you guys can see how they compare. Okay, the reason why I want to say that is because for some reason this multiplying every term by the LCD, it does confuse some children. And whatever suits you is perfectly fine. Personally, it doesn't confuse me, so I like doing it, okay? But from a teacher's perspective, I found a lot of people prefer doing this, getting the same denominator on both sides, okay? And then the horrible magic word that we say is drop the denominator. But I want you to think logically. It's not just disappearing. We're not just dropping it. We're saying, okay, both sides have to be equal. My denominators are equal, so now my numerators must also be equal. So that's what I'm actually doing. I already know my denominators are equal. I don't have to worry about them anymore, so they drop. Okay, I don't like the word because it loses mathematical understanding, but that's why we then focus on just the numerators, which is what we've got in this line here. And then you're back to normal. You multiply out, get your x's together. Okay. So that is the big thing about your fractions. When we're adding or subtracting, please remember, factorize LCD for adding and subtracting. Okay, here's another example. Okay. You will sometimes get fractions where we are multiplying or dividing. I don't think there's an example of that. So multiplying and dividing, please remember to factorize, but you don't have to get an LCD. Now, this is what I was jumping to earlier, your trinomials in equations, okay? And we call them quadratic equations. We recognize it because we've got an x squared. So the first step is standard form. Okay, that's what they called it in the expressions part. But the thing that makes it different is there's an equal sign. So we've got equals 0. Okay, so standard form. Then you're going to factorize. Now this here, this little diagram is a fancy little diagram to help you to remember the method for factorizing. Okay, because all of your possibilities for factorizing are still valid. Okay, highest common factor, binomial or trinomial. So 2 terms or 3 terms. Then if it was 2 terms, you're going to do difference of squares or the sum and difference of cubes, okay? And then the factorizing, if it's a trinomial, it's your quadratic formula, okay? Well, not your quadratic formula, you guys don't know that yet. Don't know that one yet either. But here you're going to do either your grouping method that we showed you, but this is basically when you get it into 2 brackets, okay? So that's what this diagram is for. So here, get everything to one side. And we put it in standard form. So the x squared is first, then the x, then the -3. Okay, now here they've jumped straight into those factors. If you can do that, please, I highly recommend, try to practice that. Basically, to get the 2x squared, I needed a 2x and an x. To get the 3, I needed a 1 and a 3. Then my inners and my outers have to give me that middle term. Okay, so that takes a little bit of work and playing around with. But remember the way we showed you, we would have gone 2 times 3 and we would have got 6. We would have looked at all the factors of 6. So it's 1 times 6 or 2 times 3. Which of those would give me the positive 5? Now the trick here is both of them can, because I could get it by going 6 minus 1, or I could get it by going 2 plus 3. So either positive 6 minus 1 or positive 2 plus 3. But take note, please, that I actually need to get a -6 because it was actually 2 times -3. Okay, so for me to get a negative value, I need my signs to be different. So it's going to be that one. Okay, so if we're using that grouping method, we are now going to have, sorry, from here, we're going to write it as 2x squared plus 6x minus x minus 3 equals 0. Taking out a common factor from our first terms, I get 2x. Taking out a common factor from our next terms, and then taking out your common bracket. And you notice you get exactly the same brackets as we got over there, but it does take longer. Okay, so if you can play around and try and get straight to the brackets, guys, I do highly recommend it. And then you split up each factor equal to 0 and you solve. You'll get 2 answers, guys, and you have learned how to draw the graphs of these guys. Okay, you should know that that looks like a parabola. So it makes sense that we get 2 answers because it crosses the x-axis twice. Okay, so that's the reason why we get 2 answers. But we're not doing the graphs tonight. You'll be practicing that another time. Okay, so here's another option where you got the squared for the whole bracket. Just remember when you square root both sides, so there's an alternative here, you can square root both sides, it could be positive or negative. So you have to answer that in two separate equations if you do that. Okay. And that is the end of equations. So guys, let's go back to our questions and memos, and I hope you're ready and got your thinking caps on so that we can practice all of these equations. And then I'm actually hoping that we can also do a little bit more of the algebra. We can maybe do some of the tough algebra questions. Okay. So here's some equations, question 2.1. Okay, from the equations and inequalities. Let's start with this very first one. Okay, so the first thing that's already come through is a suggestion to cube root. Okay, be careful, it can be very tempting to cube root. But if I were to cube root that, I first of all don't know what the cube root of 9 is, and I also can't cube root the x. Okay, so the fact that we've got more than one term with an x in, guys, we still want to get all our x's together. Okay, so we're still going to get all our x's together. And that's going to leave me with this x cubed minus 9x is equal to 0. Okay, yes, Klingiwe, that was brilliant. Okay, there was also a suggestion because they've seen the exponents and getting the bases the same. Guys, remember the bases are the same when they're numbers. Okay, so please don't get confused. If I had 27 to the x equals 3, then yes, I would write that as 3 to the 3 all to the x equals 3. That's where I get the bases the same. And guys, this is important because knowing which method or process you need to start with and being able to identify that's probably the most difficult thing in maths. Okay, so when you see this question, thinking about all your options is exactly what you need to do, but don't just think about it and jump into it. Make sure you know where that would be leading to. Okay, so think a little bit deeper instead of just jumping. Okay, so here I noticed that the same bases aren't going to work because I need the bases to be numbers. The x would be in the exponent for this method. Okay, so we're not doing exponential equations. Cube rooting is not a bad idea, but I don't know what the cube root of x is. So the last thing I've got is making one side 0. Once I've made one side 0, so this is almost like when I said we got quadratic trinomials, and I suppose I was a little bit, well, not a little bit, I was wrong. You won't only get quadratic, but most often you get quadratic because this is cubic. It's got an x to the power of 3. But our next step, what was our next step after making the one side 0? It's our favorite F word. Well, my favorite F word. Factorize. Yes, thanks, guys. Factorize. Okay. So I know it's not an x squared, but you make the one side 0. We are going to factorize. What kind of factorize can I do here? I already saw an answer from one of you guys. Yes, it's Komotso, I think. Sorry, half your name has been hidden. Okay, yes, thank you, Josh. Thank you, Emma. Yes, we're going to take out the highest common factor, and my highest common factor is x. What would I get left with when I take out the x? Okay, there would be an x squared. And then there would be a minus 9, absolutely. And we're already got everybody jumping on board now. So after that, always make sure you factorized completely. So I've seen Chloe, Emma, well done. Difference of 2 squares, dots, yes, Josh. Okay, so we're going to have x plus 3 and x minus 3. Okay, and then once we've factorized as far as we can, we're going to split up our factors. It's kind of called the zero factor law, but it's not officially a mathematical term. But every single one of those factors could be 0, guys, including the one that's not in a bracket. So you're going to have x is equal to 0, or x plus 3 is equal to 0, or x minus 3 is equal to 0. Okay, that gives me x equals -3. This one gives me x equals +3. So there are 3 possible answers. And the reason why is because we started off with an x to the power of 3. Okay, making sure my pause is making sure everybody's okay. If you've got a question, unmute, type in the chat, speak to me. Otherwise, we're going to be moving on to question 2. So let's have a look at number 2. Remember, they've said solve for x, and that means they basically want us to get x on its own. Okay, so solve for x means get x on its own. So this is one of those literal equations. The reason why they call them literal is because they've got lots of letters in them. I need the x, so I'm putting a little dot underneath the x. I need the x to be on its own. What's the first thing I can do to get the x on its own? Okay, now it's a lot of letters that you'd have to type out here. So I just want you to explain the operation. So add, times, divide, square root. Type in the chat and tell me what's the first thing you do. I'll put the bits and pieces together. So tell me if you're going to divide, multiply, square root. Okay. Yes, Klingiwe. Yes, Kopotso. Okay, depending what you want to, Natalia, you might be okay with it. Okay, so I'm going to start with my very first suggestion, and I want to get rid of this entire bracket. Do you notice it doesn't have any x's in? So if I want x on its own, then I'm going to leave it there. Now, one of my suggestions was multiply. And depending on what you multiply by, it's not necessarily wrong, as long as you weren't wanting to multiply in, because then we're creating more x's. If they've told us to solve for x, we need to get x on its own. Okay, so please make sure you realize that if we're trying to solve for x, we're trying to get x on its own. So we don't want to create more of them. So I want to get rid of everything that doesn't have an x. So I'm going to get rid of that entire bracket. And we've got to do the opposite operation. So at the moment, there's multiplication happening in between it. So to get rid of it, we're going to divide by the entire bracket on both sides. Okay, so I'm going to land up with p divided by that entire bracket. And that's going to leave me with the 3/2x. Okay, and Mokhadi, yes, you're completely correct. Carrying on with that. And same with Klingiwe. There's 2 ways to think about this one. You can either times by 2, divide by 3. So we can times by 2 to get rid of the 2, and then divide by 3 to get rid of the 3. Or we could divide by the entire fraction 3/2. But what happens when we're dividing by fractions? We tip in times. So that's the same as timesing by 2/3. Okay, now I've shown you 3 different methods there. Please don't try and do all of them. Okay, they're different methods. So this is method 1, method 2, method 3. You do what you're more comfortable on. If any of that freaks you out, please tell me right now. But basically, you should land up with 2p over 3 times by that whole bracket at the bottom. And that gives me the x. Okay, please let me know if we're all happy with that. If there's something that's concerning you, please let me know. Otherwise, the silence tells me we're all good. Moving on to the exponential equation. Thank you for the thumbs up. Okay, exponential equation. So here again, please remember there's different types of exponential equations. There's the one where we've got to try and get the bases the same. Okay, so the minute we see equations with exponents, there's the one that we've got to try and get bases the same. But that is when the variable is in the exponent. That's for the variable in exponent. Okay, the other method is we're just trying to get the x on its own. Okay, isolate the x, and that is if the x is in the base at the bottom. Okay, so please pay attention to what your bases and your exponents look like. Okay. So let's have a look at this first question. What is the first thing we're going to do? And you can write completely in the chat because now we don't have fancy long expressions. What is the first thing I'm going to do? I need to get the x on its own. I need to get the x on its own. What is the first thing I'm going to do? Yes, awesome, Dimple. Awesome, Emma. Awesome. Oh, sorry, it just keeps on. Tato. Okay. Keeps on flying. I missed some of the names. Well done, guys. So we're going to divide by 3 on both sides. I get x to the 3 over 4. And when I divided the 81 by 3, I'm going to get 27. Please check me because I did that in my head. Okay. Guys, now the x to the 3 over 4, depending on your teacher, they might have shown you that you can kind of do this, okay, to the power of 4 over 3, because when you multiply the exponents, they're going to cancel, okay. I don't really want you to do that though, and it'll become more prominent in grade 11, okay, than it is going to be in grade 10. Sorry, and now I've just deleted everything. Okay, so it will become more prominent in grade 11, but it's more of an understanding thing than anything else. Because if you don't understand where it's all coming from, then you are going to 3 over 4. Okay, then you're going to land up making mistakes at certain places. So I'm going to tell you to change it into third form. Okay, so whenever there's a fraction exponent, so this is why I know I can change it into third form. I'm going to change it into third form. That means with the square root sign. Roots of trees are underground. So the guy underneath the 4 is going to become the root. Okay. The number on top is the all-powerful power. So it stays a power. So basically what I'm going to have is this is going to become x to the 3, and it's going to be the 4th root. Okay. X to the 3, and it's going to be the 4th root is going to be equal to 27. Okay. Now it might be a little bit tricky to try and see if they've said without a calculator, which I don't think they did in this question. Oh, it did say without the use of a calculator. Okay, apologies. Okay, so now it's a little bit difficult. I don't know how to go 27 to the power of 4 without trying to work it out. Okay, on my calculator. But that's exactly what we're going to then do, but in exponential form. So the next thing I'm going to do is the 27, I know is the same as 3 to the power of 3. We're leaving this side untouched. And now I'm going to go to the power of 4 on both sides to get rid of that power of 4. And that's going to give me x to the 3 is equal to 3 to the 12. And then I'm hoping here, when you do the cube root on both sides, you're going to land up with x is equal to 3 to the 4. Okay, if you're not too sure how I got the 3 to the 4, basically this 3 to the 12, I know is the same as 3 to the 4 times by 3 to the 4 times by 3 to the 4. So that's why I know that the cube root is going to be 3 to the 4. Okay, we've got 10 more minutes. X is 3 to the 4. Guys, obviously, if you work out 3 to the 4, that is 81. Okay, so there's a solving simultaneously equation. Before I do that, I want to do the inequality. So we're going to jump down a little bit to question 2.2b. I will still do a simultaneous equation with you. We've got 10 minutes left. I would like to do this inequality and then one simultaneous equation. And then, guys, the rest is for you to practice, because we all know you're all looking forward to doing some extra stuff on your own. Okay, let's have a look at this inequality. Remember, the whole idea here is we need to get x on its own like we do in an equation. We do have two x's, so we're going to have to somehow do things to group those x's. So earlier somebody suggested multiply out, and I said no, because it was creating more x's. So this is the thought process that I need you to realize. Multiplying out was sometimes the correct thing, and in fact in this situation it is. And I want to make sure you understand, how do you see here, if I multiply the 3 in, I'm not creating more x's. I'm just somehow getting that x so that I can separate it from the 7. So at the moment he's in the brackets with the 7. Okay, so that's our first step. We are going to multiply out. I'm going to write it underneath. Please, it's not the story sum. Okay, so we've got 3x plus 21 less than x over 2 plus 1. Okay, the second step is dependent on you guys. So I'm going to ask you guys what you want to do for your second step, because it depends how comfortable you are with fractions. So I know what I would do, but I want you to remember we're trying to get the x's on its own. What's the next thing you would land up doing in this to try and get the x's on its own? Because it said solve for x in the inequality. Okay, so Dimple said one thing, Emma said the other thing. Okay, so there's two things that I think are correct, and Dimple and Emma immediately separated. Okay, Natalia, that is perfectly fine. That would work as well. Okay, and I don't have any more messages coming through. Okay, guys, so for me personally, I don't like fractions. So I'm going to stick to that method because I think the majority of you guys don't like fractions. So my first thing is I want to get rid of this denominator of 2. So I'm going to do the same thing on both sides. I'm going to multiply both sides by 2. Please notice the entire left-hand side and the entire right-hand side is getting multiplied by 2. So both terms have to get multiplied. Okay, so the 3x is going to get multiplied and the 21, the x over 2 and the 1. Okay, it is not the only way to do it, as I said. So Natalia was fine. Your method would have worked. It would have been a fine starting point. And Dimple, yours also. Perfectly okay to start with that. Okay, so if you did start with that, carry on and make sure you get to the same answer. Okay, then 2 times 21 is going to be 42. Then do you see I'd no longer have that fraction, because x over 2, when I times it by the 2's cancelled. Okay, now we're going to get the x's all together and the numbers all together. So I'm going to move my x's to the left, my constants to the right. So please, are we all happy that we get 5x less than negative 40? Okay. Lastly, we got to get the x completely on its own. So what is the very last step here? Type it in the chat. Type it in the chat, the very last step here. Okay, or the answer, yes, Emma, yes, Kapotso, yes, Dimple, yes, Nazar, yes, Natalia, brilliant. Okay, so we're going to get x less than negative 8 because we divide both sides by 5. The second question says, to represent your answer on a number line. We're going to do number line and interval notation. Why? Because I'm making sure you're completely ready for your exams. Okay, so they can ask you either one of these and you'll be okay. So on the number line, you do not need to put every number. You just need to put the important ones. So the only number I've got in my answer is the negative 8. It's the only number that's going to be on my number line. Okay, does it have the equal sign? No, it doesn't. So is that going to be an open dot or a colored in dot? Open or closed? Open or colored in? Yes, open. Brilliant. Well done, guys. And then is my line going to go to the right or to the left? Look at what the crocodile would rather eat. Okay, and the X is on the other side. So the X is smaller than the -8. Yes, brilliant, guys. It's going to go to the left. Okay, now if I want to do that in interval notation, it's from smallest to biggest. So if it's going to the left forever and infinity and beyond, it's going to -infinity is my smallest value, -8 is my biggest value. Round or square bracket for the -8? Round or square bracket? Round, brilliant. -8 gets round because it doesn't have the equal sign, and infinity always gets round because it's not an actual value. You cannot be equal to infinity. Okay, let's do one simultaneous equation. Okay, and I'm choosing a hectic one. Question C. Okay, choosing a hectic simultaneous equation. Guys, so it is hectic. And I'm going to need a lot more space. So I'm actually going to write it down on the side here. So we've got 4x squared minus y squared is equal to 171. And then I've got 2x minus y is equal to 9. Okay. The first thing they actually asked us for was to solve for 2x plus y. Okay. First thing they asked us to solve for was 2x plus y. So now if I have a look at these two equations, the second one doesn't have 2x plus y in it. And it doesn't look like the first one has 2x plus y in it. But guys, I promise you, if they've asked us for 2x plus y, there must be some way we can create a 2x plus y somewhere. Okay, so I want you to have a look at those two equations and see where could I possibly create a 2x plus y. So we don't panic. We actually have a look. Where could I possibly create a 2x plus y? Are there any thoughts or ideas? Otherwise, I shall give you a hint. Thank you, Emma. Okay, I'm waiting to see if anybody else can see it. Yes, Nazaha. Nazaha, I hope, I'm sorry, I feel like I'm butchering your name. And okay, Natalia, the right's very close, but it's got the negative. Okay, so there's an idea about doing the whole change the sign thing. Guys, remember, I want the change the sign will actually change the sign of everything. So if I were to take a negative out, then that's going to become y minus 2x is equal to 9. Okay, which would be y minus 2x is equal to -9. I still don't have the 2x plus y. Okay, so I'm so glad you're thinking about that, but please remember taking the negative out actually changes the sign of both of the things. Okay, so we've all tried, and I thumbs up to all of you. You guys have been absolutely fabulous. Some of you got it right. First few people said, let's factorize the left-hand equation. Do you see that this part here is the difference of two squares? So I'd have 2x minus y and 2x plus y is equal to 171. Okay, now the question said, calculate the value of 2x plus y. So I'm going to have to kind of solve simultaneously over here at the same time. Okay, so do you see here, I've got something for the 2x minus y. That guy there can become 9. Okay, we're just going to finish this question, guys. Push through with me. So we're going to have a 9, and then 2x plus y is equal to 171. And then we can divide both sides by 9. And that tells me that 2x plus y is equal to 171 divided by 9, which I want to say is 19. Thank you, Emma. Thank you, Dimple. Okay, are we all okay? That's the first question. Notice I didn't need the value of X. I didn't need the value of Y. They asked for 2X plus Y. Okay. Now that's given me these two equations. I've got this equation here and that equation there. So it's two equations and they're now asking me to solve simultaneously. So I just want to get a bit of a vote to see what we all prefer. So you've got a choice between elimination or substitution. Type in the chat whether we want to do elimination or substitution. It is your choice. Okay. Got 1, 1. Oh, okay. There's a lot more that have come through for elimination. Great. So I'm going to do the elimination. It is definitely the quicker one of the two. I will do substitution afterwards quickly so that you guys can check and see if you know what to do where. Okay. So the first thing I'm going to do is write these guys underneath each other. So I've got 2x plus y equals 19. And the reason why we know that this is going to work is because, do you see, when I add them, the y's are going to cancel out. They're going to eliminate. So when I add, I get 4x, the y's cancel out, and I get 28. Divide by 4 on both sides, and we get 7. And then you're going to take the x and substitute back in. And you're going to land up getting y is equal to 5. Okay, so make sure you can get the x equal to 7, y equal to 5, purely because I've been asked, and you guys, I definitely want to make sure this is as beneficial for you as it can be. We've got two different equations here. So I'm going to write them again, and I'm now going to do it using substitution. Okay, just to be different, I'm going to use the equation on the right-hand side. And I'm going to get the y on its own. The reason why I chose to get y on its own is because the x is attached to a 2. Okay, so I would have had to divide by 2 and I would have got fractions. Then I go back into the other side. So everywhere I see a y, I'm going to replace it with the 19 minus 2x. Remember, this negative belongs to both of them. So I get 2x minus 19 plus 2x. I'm going to add 19 to both sides. And again, I get x is equal to 7. I substitute back into the other side. And again, I get y is equal to 5.